Okay, so now we'll be seeing the cell bias circuit. As I told you previously, we had seen a fixed bias circuit where we are connecting a DC source, that is VGS, a negative supply, and VDD, a positive supply. Two supplies we used to connect. That's why it is called as a fixed bias circuit, because VGS here is a fixed value and depends on this supply, normally given by VGG instead of VGS. And this resistance, whatever we are connected, is called as RG because it is connected to the gate terminal. That's why. Similarly, we have made a cell bias circuit which does not include any other power supply, just like VGG or VGS. Only VDD supply is there. RG is the resistance connected between gate to ground. RS is the resistance connected to the source terminal and ground, and RD is the resistance connected to the drain of the JFET. And we are taking output voltage from drain terminal. Now here, as we had seen, this Vs and Rs is given by Thevenin's equivalent, which is a AC voltage source connected to the gate terminal. Now here we used to call this as a capital RS, but now we'll be changing this to small rs just because we are having one more RS resistance here, which is now called as a source resistance at source terminal, and this is a output impedance of Vs RS. So that's why we have changed this name as small r and s. So this is what is called as cell bias circuit. Again, there are coupling capacitor here, CC1 and CC2. These are the two coupling capacitors. I told you last time also why this coupling capacitors are needed. Same function of the coupling capacitor is here also. This is a complete circuit which has AC as well as DC. Before going to considering the AC analysis, we'll see how the DC analysis takes place and what all the factors you have to consider while analyzing the DC. So while analyzing DC, few things you have to keep in mind, and those few things are: 1. Short circuit all capacitors. Why we are short circuiting all the capacitors? Just the reason is Xc of the capacitor is given by 1 upon 2 pi Fc. So as we are saying only DC analysis, for DC F is equal to 0. So when F is equal to short circuit nahi, open circuit all the capacitors. So Xc, which is given by 1 upon 2 pi Fc, and F for the DC is equal to 0. So when this is 0, so this becomes Xc becomes infinity. Xc is the opposition provided by the capacitor to the flow of current. So as this is infinite, there is no current flowing out or in. So that's why we used to call as capacitor blocks DC and passes AC. Similarly, there is no current flowing here, neither at the back. So we are open circuiting it. That is the reason why we had said open circuit all the capacitors. So no capacitor, so no current flowing in this path. No capacitor here, so no current flowing in this path also. Hello.